Hi again, Pre-Calc students. It's time for another online lesson. We're a little bit behind here, it seems like, so this is lesson 2.6, Systems of Linear Inequalities. This will be a pretty brief lesson here, I think. First of all, whenever you hear or see this word here, this phrasing of graphing inequalities, one thought should pop in your mind, and that is shading. We're going to be doing some graphing that will involve some shading of regions to show where the solution is. And then when you see this word system right here, system of equations is what we've been working on earlier in the chapter. When you see system of inequalities, the word that might pop into your mind is this, solution. Because when we solve systems, we are looking for a solution. So in this case, our solution will be a shaded region, but it'll even be more specific than that. Now, one thing is you can see on our slide here, the vertex theorem is kind of a key thing. The maximum or minimum value of a given function occurs at the vertex of a polygonal boundary. Now, the vertex is a corner point. We'll be able to see this in the example that we do. Our first and only example, really. These are the kind of problems that are in lesson 2.6. So it says find the maximum and minimum values of this particular function if we graph these inequalities. We'll try to do this in several different colors here. So first of all, x is greater than or equal to 0. I'll try to do that in red. If you imagine x values, where would they be bigger than 0? Well, really everything off to this side here. I'm not going to shade that. Rather, I'm just going to kind of draw a little arrow like this, that if I was shading it, it would be that whole region. In similar fashion, for the y one, I'll try to show that in green. The y values, of course, would be anywhere really in the same region when y is bigger than 0. And so that would be shaded up like that. Now we get to the ones that are a bit tougher, but still not too bad, I don't think. This next one, 2x plus y less than or equal to 4. I think you see I could perhaps rewrite this as y is less than or equal to negative 2x plus 4. And so I could graph that as I would a line, the y-intercept being 4, and the slope of negative 2, so I could go down 2 and over 1 like that, down 2 and over 1. So really then that would be the line that looks like this. And my shading here, because it's that less than symbol, would also be to the left. So it would be going down like this. Alright, and then my final one, I'll see if I can switch colors here yet again with a one we haven't seen before. X plus y is less than or equal to 3. This is kind of a good one to maybe just use the intercept method. And so the intercept method here would show that if x were 0, y would be 3, and if y were 0, x would be 3. So that is going to look like this. And again, its shading would be to the left because it's less than. So perhaps you can picture now, I think, my final shading where all of these intersect is going to be this region right here, which I'm shading like that. And what I want to check now, according to that vertex theorem, are the corner points. So I'm going to check this point right here, and this point here, and this point here. And I am going to check that, remember, with our function that we had earlier, which was x plus 2y plus 1. And I'm going to see what kind of values I get out of all of that. And the points I'm going to look at then are, first of all, this one up here, which is the point 0, 3. And then the one in the middle right here, which is the point 1, 2. And then we have our point in the corner here, which is 2, 0. And technically, I'm also even going to check the point 0, 0, which is way down here. And if I put these values in for the x and y, I'll try to do this fairly quickly here. I think I'm going to get 7 when I do this. Again, I put 0 in for x and 3 in for y, so my total is 7. For 1, 2, I believe my total is 6. for 1, 0, excuse me, 2, 0, my total is 3. And for 0, 0, my total is 1. And so when remember I was trying to look for my maximums and minimum values here. So it looks like this point here, 0, 3, that's going to give me my maximum. And the point 0, 0 is going to give me my minimum, which is 1. All right, so that's about it. We'll practice some more of these when we get to class tomorrow. Also have a special guest here that I'm going to have her say hi really quick. The first person that tells me who this person is, I'm going to give you some extra points on the right side of your assignment card. So special guest, why don't you say hi to the pre-calculus students.
Hello.
All right, thank you, special guest, and we'll see you guys in class tomorrow. Bye now.